Welcome back, everyone. Next up, we have Odyssey Semiconductor Technologies, Inc. It trades on the OTCQB under the symbol ODII and has developed a proprietary technology that is designed to allow for GaN to replace silicon carbide as the emerging high-voltage power switching semiconductor material. Based in Ithaca, New York, the company owns and operates a 10,000 square foot semiconductor wafer manufacturing facility, complete with a mix of Class 1,000 and Class 10,000 clean space, as well as tools for advanced semiconductor development and production. Odyssey Semiconductor also offers a world-class semiconductor device development and foundry service. Please welcome its CEO, Mark Davidson. Welcome back, Mark.
Thank you so much for having me. So, and thanks for the introduction. Thanks to Emerging Growth Conference for hosting us today. So again, Mark Davidson, I am the CEO of Odyssey Semiconductors, ticker symbol ODII. Today, I'm thrilled to announce that we have delivered product samples to our initial customers as per our press release. It was yesterday, April 4th. At Odyssey, we are passionate about enabling the electrification of everything with sustainable solutions. Our team of experts has been working tirelessly to develop innovative solutions that can meet the growing demands of power electronics where pure silicon and silicon carbide fall short. I am proud to say that our product samples have received product feedback from our initial customers. Our solutions offer a unique combination of high performance and solution level cost savings, making them ideal for a variety of high volume applications. Vertical GaN for power applications will change the game, and Odyssey Semiconductor is uniquely positioned to capitalize on it. We have highly valuable and protected intellectual property that allows vertical GaN to be consumed in high volume, one of the challenges that the silicon carbide companies are struggling to solve. From our expertise to design vertical GaN products, to our 10,000 square foot facility where we develop and where we will manufacture our products, we have everything needed to deliver on the market opportunity. Speaking of the market opportunity for Odyssey is large and growing fast, approaching over $5 billion over the next few years, mostly driven by electric vehicles, industrial motors, and renewable energy. All markets that are dependent on high voltage, high efficient power conversion and energy conservation. As I mentioned earlier, electrification and sustainability are two of the main drivers where our vertical GaN technology is required. We have received tremendous interest from customers who are looking for reliable and high performance solutions that can help them achieve their business goals. Our customers include some of the largest players in their respective industries who have been impressed with the technical progress we've made. Our roster of engaged customers is impressive with some of the most recognizable logos in the world. Specifically for electric vehicles, our vertical GaN devices will be used to extend the range of electric vehicles and accelerate charge times while also providing system-level cost savings. To Odyssey, we'll be capitalizing on high-margin, high-volume business opportunities. Our team is and remains committed to delivering the best possible solutions to our customers, and we're constantly working to improve our products. We have several exciting developments in the pipeline, including product development agreements with large customers and strategic partnerships that will further strengthen our position in the market. In conclusion, at Odyssey Semiconductor Technologies, we're passionate about unlocking the full potential of vertical GaN technology for power applications and to solve real-world problems. We're excited about the market opportunity, customer interest, and technical progress we have made so far. And we look forward to continuing our journey with you. Thank you for your time.
Great job, Mark. Okay, so we have a question from Ralph B. The samples you delivered, what does that mean for growth going forward?
Yeah, so the first job we wanted to do as an early stage company and a brand new technology is prove to a couple lead customers that we truly have developed a vertical GaN transistor, and that what we'll call the money specs that people expect from vertical GaN truly are being delivered. And those money specs are the blocking voltage, so how much voltage it can withstand, what the on resistance is. So in these transistors, on resistance is a very important spec. The on resistance for a given die area, and then something else called input capacitance. Those are the three main money specs. So we wanted a few of our lead we'll call them friendly early access customers, to test them and say, yeah, you truly do have the voltage, you have the on resistance, and you have the switching frequency. So now that we've done that, now we use that as, kind of that third-party proof to say, okay, let's go figure out how do we make these products exactly what's needed for certain applications. So that product will be great for industrial motors. We use that to work with the electric vehicle companies to say, okay, based on that platform, how do we modify it to be something that's really relevant to traction inverters in an electric vehicle, et cetera. So we used it to prove that we truly have this device. And now we'll work with customers to say, okay, how do we, what needs to be done to the product to make it ready for large scale consumption?
And does this exceed your original expectations?
I have very high expectations, so no, but I'm very pleased with what we've delivered. The fact that we got the positive feedback, it was aggressive. It was an aggressive goal for us to sample customers in Q1 of this year. And I think I used that exact term in the press release. So the fact that we were able to do it, I can tell you that people worked their butts off to make sure that we did it. So expectations were high, very proud of that accomplishment. We have work to do still, of course, until we get to revenue, but proving to the customers and to the market that we're building vertical GaN transistors, it was a really, one heck of an accomplishment.
Joe Reynolds would like for you to go over your revenue model.
Yeah, so we're a product company. We will be shipping product in the millions. 2025 is when that type of product revenue starts. In the meantime, we're looking to some of the lead customers to pay us upfront some non-recurring engineering and NRE payment as a way where they'll buy their way to have us build the exact product that they need, make sure they're committed to commercialization, and then we also, because we have our facility, our foundry facility, we do generate some revenue there, foundry services, but we really are a product company, and we will be selling millions of product.
And Cheryl Tate wants to know, who are your customers and what other products are they substituting for yours?
Yeah, so I talk a lot about the electric vehicle because it's such a large opportunity. Today, the move from silicon to silicon carbide has happened, and the next step is going to be silicon carbide to vertical GaN. So one example is an traction inverter in an electric vehicle. This is the thing that converts the battery voltage into the AC that's going to make the wheel spin. Silicon carbide's there now, and with vertical GaN, as I mentioned earlier, it's more efficient, it's smaller, it's lower total solution cost. What that means, not that I'm selling my chips cheaper, but that they'll need fewer of mine to do what they do with silicon carbide. So they'll get a system level benefit without me having to lower price. So that that's a great example of exactly where our technology is going to go and what we're going to be replacing, which is silicon carbide, with the goal again of extending the range of an electric vehicle. That's the money.
And Brad Hawkins wants to know, what exactly is protected by your patents? Yeah,
so anybody could draw a picture of how to build a vertical GaN transistor. Matter of fact, there's publication out there. The intellectual property is actually the material and the manufacturing process techniques used to fabricate a device that works. So we do issue a lot of patents, submit for a lot of patents. We have a couple submitted. We have a large pipeline. Some stuff we keep just as trade secret. There's certain little techniques that we don't even want to put into a patent. So it really is a combination of patent protection and then and trade secret.
And Rose Burgess wants to know, how far from recurring revenue are you?
2 years. 2 years for large scale production revenue.
And another question on revenue. Pete Edelman wants to know, how does your capital match with your product revenue timeline? And how did the changes in CHIPS Act make the grant easier or more difficult to obtain?
So I'll start with CHIPS. I would say that the grant is harder to obtain because it became a lot less valuable to a company like ours. The percent capital that they'll provide relative to what we need to provide ourselves, a lot of the stipulations tied to it. I, like a lot of semiconductor leaders, are very unimpressed with the CHIPS Act on the grant side. We do see some potential on loans and government-backed loans, et cetera. But I would say that the CHIPS Act is not really valuable to innovative companies like ours. Doesn't mean we're not going to continue to try to find a way, but right out of the gate, it's very unimpressive. From a capital point of view, in order to get our facility fully production qualified, we need about $5 million of capital. And then, we run at just under $400,000 a month of burn. And that includes some of the headcount we need to add on the engineering side, purely engineering, to make sure that we execute on the products and deliver the products. And so, right now, capital is very, very, very important for us.
And the last question is, Wolfspeed is already building major fabrication plants in New York and materials, so they expect to lower costs for silicon carbide chips. So how do you compete against them?
Yeah, great question. So at the end of the day, you look at the physics and to make it very clear, for the same product specs, if you take one silicon carbide transistor, 10 of my transistors fit in the same area. So I have a 10-to-1 advantage over silicon carbide. So yeah, they'll continue to add capacity, figure out how to yield, how to get yields, et cetera. But at the end of the day, I have a 10-to-1 advantage over them just based on gallium nitride versus silicon carbide.
Well, Mark, thank you so much for this update. Fascinating stuff, and glad to hear all this progress. We hope that you join us again soon.
Yeah, thank you so much for having me. Take care, everybody.
Okay, everyone, stay with us. We'll be right back.